Good day, guys, and welcome to Intellect Academy. I am Emmanuel, and today we're going to be talking about partial fractions. So, first of all, what is a partial fraction? A partial fraction is a fraction that can be split into what? Sum and what? Differences of simpler fractions. In this sense, for example, we have a fraction as 5 over 6. Of course, in normal cases, it's not going to come as 5 over 6. It can be 5 over 6 bracket x squared, then you have a polynomial or quadratic equation, and in any of those cases. The concept is easy. We can say this is what? An algebraic fraction. It can be splitted into what? Sum of what? Fractions. In this case, these are what? The partial fractions. And also, we say that they can be also be splitted into what? Differences. In the sense, if we have 1 over 6, for us to split this, we have 1 over 2, negative 1 over 3. So this is the concept of what? Partial fractions. Splitting or decomposing the algebraic fraction into what? Two or more simpler fractions. The concept is easy. The decomposed fraction must be simpler. Of course, this is the algebraic fraction. So that's the concept. So first of all, we must talk about what? The types of partial fractions. Of course, there are a lot of types of partial fraction. We have what? We have linear factors in their denominators. Now, take note. A partial fraction can be classified as different types of, like we say, linear, we have factorizable, we have repeated linear, we have quadratic, depending on what? Their denominator. Their denominator. Now, let's say, for example, we have a fraction like this. Let's say we have a fraction as 2x negative 3 over what? X squared plus 2x plus 1. Or let's say we have 2x negative 3 over what? X negative 1. Or let's say we have, let's say this is 1 over x negative 1 bracket x negative 2. Now you can see here that you're seeing the cases where the denominators are what? Different. The denominators are different. The function of the denominators are different. Now it is defined or it is categorized based on their denominators. So we can have a linear factor in the denominator, we can have a quadratic, we can have a factorizable, we can have repeated factors in their denominators. So those are the concept of what? Partial fractions. But we are going to talk about the methods of solving partial fractions, because if you know the methods, you can approach any type of partial fraction you're given. Of course, there are three methods of what? Solving a partial fraction, and we're going to talk about that in this video. So stay tuned, hit the like button, subscribe, and turn the notification bell on so you'll be notified if we drop more videos concerning this our channel. So hold on tight. Let's go. So we are given in this question that we should use method 1, which is the cover up method, to resolve a partial fraction, which is 3x over bracket x negative 1 bracket closed bracket open x plus 2 bracket closed. We should resolve this into partial fractions using what? Method 1, which is what? The cover up method. The concept is easy. In any question you're given that we should resolve equation into partial fraction, we must first of all bring down that equation first. So we're having a case where we're having 3x over what? X negative 1 x plus 2. Now you will put, it's more of like an equality, but it's not equality, more of like 3 signs, 1 2 3. And first of all, we must identify which type of partial fraction is this. Which type of partial fraction is this? Because we said that the types of partial fractions are what? Are given based on what? How the denominators look like. In this case, you're seeing linear, Of course, denominators are linear. So this is what? This is a linear factor in a denominator, which is a denominator has what? A linear factor, and that have three lines here. This is different from what your inequality sign. So this line is telling us that we are going to have two, since they have two roots, we have two what is like two roots here. So therefore, we're going to break this down into two different simpler fractions. So we're going to have, so we don't know the attribute of what the numerator look like. So I'm just going to assign this as a bracket. We take the first root, which is x negative 1 plus what? The next one is b over what? X plus 2. Now in this case, we have assumed, because this is like an assumption line, that this can be broken down into what? Two like this. For we don't know the value of a, we don't know the value of b, so we are going to use the cover up method to find these values. As the name implies, cover up method, it implies that if you're looking for a, you will cover up b and compare a with what we have here in this equation. If you're looking for b, you will cover up a, compare a, b, and what we have here on the left hand side. So that was the concept. So now let's start this using the cover up method. Of course, we said that, but let's look for a. So we're having for a. The concept is easy. We're going to cover up this, and if we cover up this, we're left with what? A over x negative 1, and we're left with what? 3x. Then we have this. So if we do that, we're covering b if we're looking for a, and we'll cover a if we're looking for b. So in this case, we're looking for a, we're going to cover b. So we're having this and this. So we're going to take this out. So we're having 3x over what? X negative 1, x plus 2 is equal to what? Now it becomes equal because what we did here, we assumed. Well, for the cover up method, as we cover up this will go out and left with all those two equality sign. So of course, equal to a over what? X negative 1. Okay, now what did you notice? The denominator of a in this case is what? X negative 1. The denominator of a is x negative 1. So therefore, you can see when you compare these two, you have that this will cancel one of these, right? You're not left with what? A is equal to what? 3x over what? X plus 2. Now the concept is easy. Since we are having the denominator x negative 1 as what we have under a, we're going to do a rule, which is a condition. We're going to say that let x negative 1 be equals to 0. So if we make a separate formula, we'll say that x is equal to 1. Now the concept is easy. X is equals to 1. We're going to substitute that value. So substitute, we have that a is equal to what? 3 into 1 bracket 1 plus 2, which is what? 3 over what? 3, which is equal to 1. So the value of a is 1. Okay, now so since we have successfully looked for the value of a, which is what we have here as 1, we're going to do for b using the same condition. So we're going to do for b. So we have for b, the same principle is, if you're looking for b, you cover up a. We're going to cover this a. So we're going to consider this and what we have here. So we have, of course, we're going to have 3x over what? X negative 1, x plus 2 is equal to what? B over what? X plus 2. Now what do you notice here? That this will cancel this, and you're left with what? B is equal to what? 3x over what? X negative 1. But now we're going to make that assumption, which is what we did earlier. The denominator under b is what? X plus 2. So we're going to say let, very important, we're going to say let x plus 2 be equals to 0. So if x plus 2 equals to 0, we will make x over from, you're going to have x as negative 2. We're going to substitute that here. So we have this as 3 into negative 2. We have negative 2, negative 1, of course. So this is going to amount to what? 3 times negative 2 is negative 6 over what? Negative 3. Our answer will be 2. So therefore, b is equal to 2. So therefore, we have the value of a and b. We're going to substitute that value into there. We're going to take down. So we're going back to this. We're going to take this expression we had first. So we're going to have, of course, 3x over what? X negative 1, x plus 2. Now, this in this case is not going to be the assume that we have three equality sign. Um, we're having two because we have gotten the values of a and b. So we can just substitute that value here. So when we do that, normally we have this as what? A over what? X negative 1 plus b over what? X plus 2. So since we know this, we're going to just substitute that value. We had a as 1, right? So we have this as 1 over what? X negative 1 plus what? 2 over what? X plus 2. So therefore, you can say that 3x over what? X negative 1 bracket x plus 2 is equal to what? 1 over what? X negative 1 plus what? 2 over what? X plus 2. So this is the value when we are successfully reduce and resolve this into what? Simpler or partial fractions. So the concept of cover up method is very easy. You're looking for A, you cover up B, and you take these two. You're looking for B, you cover up A, and you take these two. So there is the concept, and don't forget we assumed the value of the denominator to be equals to 0. So we can find the value of x and substitute into the equations, and we look for this. So thank you very much, and let's go on to the next method.